Good morning, students. So let us start with a new chapter today. That is module number 4. So whatever mainly theoretical and a little bit dragging sessions were there that are covered. So this last two modules actually they are interesting, and all the basics as we have done in the first three chapters. You will find in this two modules things are quite in repetitive mode. So in this chapter, what we are going to see is, so there are mainly two parts in this module number 4. The first part in the module number 4 is called as electric vehicles, and next part is called as hybrid electric vehicles. So first part is actually EV and second part is HEV. So we'll start with the electric vehicle part today itself. And in electric vehicle, you can prepare this thing from module number 5 of the book Ehsani, that is page number 95. And in this first they have given configurations of EV. So first it is said that why EV and all. uh, we are finding that it is a good substitute for the IC engine. That means we are trying to replace the petrol based vehicle with the electric vehicle, and it is having less carbon emission. It is not adding to the pollution of the air and all those things. And EV is having a lot of other advantages as well. Complexity in the mechanical design is very less. Car is less heavy, and if designed properly, so if battery management system is done properly, the EV can give marvelous results. So only downside is charging can be one of the big downside of it, and the battery performance can be one of the point of concern, because battery research is still going on, and it has increased the efficiency of the battery quite a lot over last 5-10 years. But then also a lot has to be done in battery management system and battery technology. So in electric vehicle, what topics there are 5 or 6 types of configurations of EV that they have explained. So this can be a 10-mark question. That is, what are the possible configurations of electric vehicles? And there is performance of EV. So whatever we have seen in the module number 1, the performance of electric vehicle. That is, performance of general vehicle. That is, we have seen there is something called as velocity, then there is acceleration, then there is called as gradability. Okay, all those things we have seen previously in the module 1. Same things will be discussed here, but from the EV point of view. So there will be nothing new in this. Whatever we have studied previously, those fundamentals we have to put in EV format, and then we have to see what is meant by traction motor characteristic. So traction motor characteristic we have seen in, I think in module 2 we have seen that. So initially there is a constant torque region when the speed is very less, so car has just started. After that the vehicle reaches to its base speed, and after that what we find is the torque keeps on reducing, and the power keeps on increasing. Okay, so those regions we have seen. So there was a constant torque range, there was a constant power range, all those things we have seen. Again, there will come all those things today. But performance of EV we will be studying. So from EV point of view, what is constant power, what is constant torque range, and what are different gear range. That is one gear vehicle, two gear vehicle, three gear vehicle. All those things we will see today. So traction motor characteristic, it is already known. So we are going to see the known thing in a different light. Then tractive effort and transmission requirement, what is there? And if time permits, we will see some of the vehicle performance. So gradability and acceleration and velocity, all those formulas we are going to see again in vehicle performance. So there will be very less number of things in this lecture which is new, but we are going to do everything from EV point of view. Then this module finishes with two topics. One is called as tractive effort in normal driving, and the second one is energy consumption. So with these topics, we will finish the first half of module 4. So main target is to do up till vehicle performance today. Okay, in this 1 hour lecture. So I'll go a little fast because things are already known to us. Only there will be a lot of block diagrams and configurations that I'll be explaining. So this is the first part, that is electric vehicle. In that first part, we are going to see the initial topics, that is initial two topics we will try to complete. So performance of EV, of EV is having 3 points. So this also can be a 10 marks question that explain performance of EV. That means you have to talk about all these 3 points. So 3 marks each, you can say. So around 3, 4, 3. So vehicle performance can be 3 marks, tractive effort can be 4 marks, and traction motor characteristic can be 3 marks. So this is the 10 marks question from here. And configuration of EV can be another 10-mark question. There are 6 configurations that we have to discuss. And before this, there is a big block diagram of EV configuration. So that is a new thing which we will see today. So then there is a tractive effort and normal driving and energy consumption. Hybrid electric vehicle, there are mainly 4 topics, but there are a lot more things in it. But to tell you that this module 4 is comparatively a short module. So number of topics and difficulty level of topics is quite less. This is mainly electric vehicle, hybrid vehicle, their block diagram, their block explanation, all those things are there. So after we finish the first part, maybe tomorrow we'll be able to finish the first part, or if I conduct an extra lecture. So I missed Saturday's lecture last week. I would like to record the concluding part of this first part today itself, and I will upload. So if I can do that, in that case, tomorrow itself we can start with the hybrid electric vehicle part. So if I upload that lecture, please go through it. So now I'm starting officially the module number 4, that is called as EV and HEV. So initial EV was mainly converted from the IC engine. So IC EV is called as internal combustion engine vehicle. So by replacing just the IC engine and the fuel tank with the electric motor drive and battery pack. So initially that was the understanding that only we have to supply energy, that's all. So IC engine was getting energy from engine, and there was a tank which was containing the fuel, and that was directly replaced by electric motor drive. That means instead of engine, the power was coming from electric motor and the battery pack. All other parts were retained. Okay, but this is the very initial part of the vehicle. So this is the mechanical transmission. So that differential and all those things are there, and wherever engine and the fuel tank was there, they are actually replaced by this electric motor drive. Okay, so please stay with this 1 hour in this lecture, because there are a lot of things. It will go in a evolutionary fashion. So don't leave the session immediately. So this is called as a primary electric powertrain. Okay, so here there was an engine, and there was a source of fuel, that was the fuel tank, and they were directly taken out, and it was replaced by motor drive and energy source, that is the battery. But this converted EVs were very heavy in weight, because all the gear, engine, apart from engine, all the other things were there. Their flexibility was low and performance was not very much acceptable. The heaviness was the main problem. Okay, because IC engine, it requires a lot of mechanical components, because it is generating electricity and then it is spread over through the axle and through the differential. It is given to the rear wheel, front wheel, and other thing. So this generally IC engine is very heavy. IC engine based vehicle are very heavy. So just replacing the IC engine with battery and electric motor drive, that cannot be the solution. So this is the very initial primitive electric powertrain. So this converted EV very heavy in weight, lower flexibility, and performance degradation have caused the use of this type of EV to fade out. So that means this idea, just remove the IC engine and put battery. So this idea did not work out. So in its place, modern EV is built more primitive. You can see the block diagram of modern EV just in the next slide. They're based on original body and frame designs. So instead of just a kind of a just just remove this IC engine and put EV. So this is kind of a stopgap arrangement. So instead of that, EV is supposed to be designed from the very basic itself. Okay, so EV is supposed to be designed as EV only, not as a stopgap arrangement for IC engine. So this satisfies. This means this design from the base. So EV design from the very basic. This satisfies the structure requirement unique to EVs and make use of the greater flexibility of electric propulsion. Now let us see. So in the right side, you can see there is a very big diagram, and we'll be having 3 slides on it. Left side, I'll be giving you the specifications of this diagram, and right side the same. So this is a that what is the block diagram of a modern day EV. And this is a EV block diagram which is designed from the scratch. So there are three links, and below it is given mechanical link, electrical link, and control link. So this very dark things, they are the electrical link. That means electrical power is going in that. Mechanical link only you are finding in electric motor, mechanical transmission, and wheel. Okay. So transmission, that is axle, differential, and wheels. So energy generated is going there. Only that much part is mechanical. Rest everything, all the power are electrical. So what all things we can find here? So these are the two input commands, that is brake and accelerator. We are not finding any clutch gear arrangement here. So clutch is generally not there in electric vehicles because speed control is done without clutch automatically. So this is a vehicle controller. This is a brain. Okay, so electric propulsion subsystem. So this is a vehicle controller, electric power converter, because energy is coming from battery, which is DC. But motors and all this thing, that can be an AC motor. So DC to AC converter. We have seen different chopper and other topologies here. So there's a vehicle controller, then there's an energy management unit, energy source. So this is the main source of battery, energy refueling unit. So energy refueling, in this case, it is actually the charging unit. Okay. So here, this is the energy refueling, this is the energy source, and this is the energy converter. So from this DC, it is going to this uh, inverter, and whatever inverter is giving output as AC, and that is actually driving the motor. Okay. And this is the energy management unit. So everything is here. So it is connected to battery, it is connected with the input, and it is connected with the ECU and all these things. So there is not a only one supply. So there is auxiliary supply also. So we'll discuss about it. It is written here. The auxiliary system consists of power steering unit. So power steering unit is to be given some kind of energy, because here we are actually reducing the drivability or driving difficulty of the driver. So electric power steering can be hydraulic, it can be electrical. So VLDC motor is connected there. Little bit rotation you give, direction of rotation, if the vehicle understands, it will rotate the steering in that direction. Little input, little bit of deflection, and the vehicle will move in that direction, that much. So this is more sensitive BLDC motor based thing is. So this is actually requiring power. And there is something called as hotel climate control unit. It is actually controlling the different comfort and other things inside the vehicles. Hotel climate control unit, we'll discuss about it later. And so this is the auxiliary power unit. Okay, so auxiliary power supply, power steering, hotel climate control. This is the auxiliary subsystem. And the modern electric drivetrain is conceptually illustrated here. The major three components are electric motor propulsion. So this is the electric motor based propulsion. Second one is energy source, that is this one. And third one is auxiliary. So electric motor, energy source, and auxiliary source. These are the three main points. Electric propulsion system, that means this side, left side. It comprises the vehicle controller. It is here. Then there is a power electronic converter here, because this is converting DC into AC, and that AC is driving the motor, because the motor is a AC motor. Then electric motor, mechanical transmission, and driving wheel. So this is mainly the mechanical part, starting from the energy source. The energy source subsystem, that means this part, it involves the energy source, the energy management unit, and the energy refueling unit. So refueling means recharging. Okay. So here this energy management is connected in bidirectional mode. So you see that almost all the links are bidirectional. That means it is input output mode. Okay. But from energy source to the auxiliary, it is unidirectional. So this is an intermediate kind of a power source, and it is supplying the power steering, hotel climate control, and all. The energy source subsystem involves the energy source, energy management unit, and the energy refueling unit. Last is auxiliary unit. This is the auxiliary subsystem unit of power steering, hotel climate control, and the power steering. So this is controlled by this. So there are three links. You have to understand which is which. So this links, which is shown in bit faint, these are all control signals. Whenever it is dark black, it is actually the electrical signals, and whenever it is double line, it is called as the mechanical signals. So whenever it is asked, you have to separate out all these three parts, that is electric, energy, and auxiliary, and you have to explain them separately. And mainly there are two inputs, brake and accelerator. Which one is not there, we have to understand. The clutch and gear system is not there here. Now, based on the control inputs, so these are the control inputs: brake, accelerator, and steering can be another control input. That is the direction of the front wheel and other thing. And this also can be considered. That is energy, charging energy can also be considered another input. There is not a control input, but this is another input. Okay, but control inputs are mainly three: brake, accelerator, and steering. So based on the control inputs from the accelerator, brake pedal, the vehicle controller provides proper control signal to the electric power converter, which functions to regulate the power flow between the electric motor and the energy source. So depending on the brake and accelerator, the vehicle comes to know a driver is trying to do what. Driver is trying to run the vehicle faster. In that case, more power has to be fetched from the energy source, and more DC to AC conversion has to happen so that electric motor can run fast and the vehicle can run fast. So the backward power flow. So backward power flow is also there. Backward power flow is called as regenerative braking. So you can find here from electric motor, again it is coming back to electric power converter, again it is coming to energy source. So these are the things. Okay. So that's why you should attend lecture. I'm not saying anything very different, but yes, the main points, there are few points when you are reading from the book, you might not take it very seriously, but these are the small points which are there for me to tell you. That is this backward power flow. So here from electric motor generator also you can say there is a backward power flow which is coming to the energy. See that there is no backward power flow from the steering, because towards steering there is only a forward power flow. Backward power flow happens from the motor, because regenerative braking happens and it comes to the energy source. So the backward power flow is due to the regenerative braking of the EV, and this regenerated energy can be restored into the energy source provided the energy source is receptive. Not all the batteries are having a receptive energy source. So we have to always consider to generate some power or energy by regenerative braking. So that is also a part of EV design. Initial, whenever ICEV was there, IC engine was converted to electrical vehicle. In those, this kind of regenerative braking and adding to the energy source, that is, we are adding some energy to the energy source during braking. All these things might not happen there. So regenerative braking is a electrical concept which has to be specifically designed for EVs. So most EV batteries as well as ultra capacitors and flywheels readily possess the ability to accept regenerative braking. So that's why previous chapter is important. Your attendance was very low in the previous chapters, but go through that chapter, because that is our field. That is the field of electrical electronics engineers. That is EV, ultra capacitor, EV battery, flywheel, regenerative braking. All these are research topics, and your future research or future work can be in that dimension. Okay, it is a little dry, it is not as interesting as you think, but those are our topic, electrical and electronics related. So most EV batteries as well as ultra capacitor, flywheel readily possesses the ability to accept regenerative braking. How it is, how they accept power from the output side, we have seen in the previous slide, a previous chapter. So the energy management unit, that is this one, that is the BMS. This also was a topic in the previous chapter. There is battery management system. This actually cooperates with the vehicle controller to control the regenerative braking and its energy recovery. So BMS is a controlling part in energy recovery, we know. Then it also works with the energy refueling unit to control the refueling, to monitor the usability of the energy source. That means how well the energy is being used. That is another thing. So different conditions might be there. There might be a steep up, there might be a slope down. Okay, and there might be reverse up, reverse down. So all those things. So every case, how to use regenerative energy, that thing is continuously tracked by the energy management system. So it also works. So this energy management unit, it also works with the energy refueling unit. That means this one. So initially I told you that this is a bidirectional and very important bidirectional arrow. That means how to refuel the battery continuously is being tracked by the energy management unit. So monitor the usability of the energy source. So final line, the auxiliary power source, this one, the below right block. Auxiliary power supply provides the necessary power with different voltages for all the EV auxiliaries, especially the throttle climate control and power steering unit. So whatever power steering, whatever song and all we hear, that's the audio part. Whenever the vehicle is going back, at that time there is a sensor and there is a video we find out during parking. Then there is the AC. Okay, and there is the internal lights, all those things are coming under the auxiliary use. So main use of electricity is the motor. Auxiliary use are all these things that I have just explained. So all these things are actually controlled by the hotel climate control and power steering unit. So for that also minimal amount of DC energy is required, or that is given by the energy source. So conceptual illustration of general EV configuration. If this question is asked, this block diagram you have to draw, and you have to explain three cases, three things. That is, first one is the electric propulsion subsystem, second one is the energy source subsystem, and third one is the auxiliary subsystems. So these three things has to be explained separately. This is a 10 marks question. Next is, what are the different configurations of electric vehicles? So there are a variety of possible EV configurations. There are actually 6 that we have explained here due to variations in electric propulsion characteristic and energy sources. So in the first case, this is a very primitive thing, okay, and this is figure A. This is a very primitive thing. Here we can see there is a clutch, so clutch is not here. There is a differential, so differential is actually taking the power from the axle, from the engine or motor, and then it is going back and it is giving the power to both the rear wheels. And we have seen that rear wheels are something which is actually pushing the vehicle front, okay, and front wheels are actually giving the direction. So rear wheels are given the main power, driving power, tractive force is given to the rear wheels. So figure A shows the configuration of the first alternative in which an electric propulsion replaces the IC engine of a conventional vehicle drivetrain. That means initially whenever ICEV was there, that ICEV we removed the IC engine, we removed the that is the fuel source, and we have replaced a motor and a battery in that. So this is a very primitive type of this very primitive type of electrical vehicle that we have seen. It is there. So what all things are there? There is a differential, okay, there is a GB is the gearbox, so it was an electrical vehicle with a gearbox, and there is an electric motor. Okay, so there is an electric motor, and between electric motor and GB, that is a gearbox, there is a coupling arrangement you can find. So in the next edition we will find that this thing is gone. Okay, so there is a coupling, this thing is gone in the next design, that is figure B. We will see that. Okay, so what all things we can find here? There is electric motor, there is a coupling, there is a gearbox, and there is a differential, and this is the steering wheel. So figure A shows that the configuration of the first alternative in which an electric propulsion replaces the IC engine of a conventional vehicle drivetrain. So just now, whatever previous diagram we have shown, this is a very properly designed EV. Okay, and this vehicle, whatever you are seeing, figure A, it is not even closer to the diagram shown before. Okay, so whatever you are seeing here, it's just a primitive thing. ICEV was there, we have removed the engine and we have replaced it by a electric motor. So that's why we are getting a very primitive kind of a configuration. Then also we should talk about it because it was the initial configuration. So it consists of an electric motor, clutch, gearbox, and a differential. The clutch and gearbox may be replaced by a automatic transmission. Okay, so that is what is shown here. So the clutch is used to connect or disconnect the power of the electric motor from the driven wheel. We know what does a clutch do. The gearbox provides a set of gear ratios to modify the speed, power, torque profile to match the load requirement. So not every time we are running the vehicle with the high speed or high power, high torque. Initially we are starting with high torque. Okay, that is gear 1, gear 2, they are high torque. Okay, and at that time speed is less. But as vehicle is coming in the running mode, we are increasing the speed, and we are running the vehicle with higher speed and lesser torque. So this changes, actually changeovers are happening by using the gear. So the differential is a mechanism or a device, or it's a mechanical device, usually a set of planetary gears. So differential video I will post in the group today. It's a very interesting video. Please check that. So the differential enables the wheels of both sides to be driven at differential speed when the vehicle runs along a curved path. Whenever the vehicle is taking a turn, at the time both the back wheels, they are not running with the same velocity. How that happens, that is actually explained in the gearbox. So today I will upload the video. Please check that gearbox explanation. It is nothing but some gears and all those things, they are connected in ratio. It's a remarkable design. Please check that. So there are few, some 5 6 different gears in the differential. Okay, so the differential is a mechanical device, usually a set of planetary gears, which enables the wheels of both sides to be driven at different speed when the vehicle is taking a turn. So that was the first part. Second part you see, so just check here, M and GB. M is the motor, GB is the gearbox. So between M and GB, previous case there was the something coupling. Okay, and this may be I think it is mentioned here. The clutch is connect or disconnect, gearbox provide gear ratio, differential clutch gearbox. Okay, so this coupling is not there. Okay, there is a power converter and all, it is not there here. So you can find that with an electric motor. So there's a figure B with an electric motor that has constant power in a long speed range. So the vehicle motor characteristic has been defined. It has a constant power in the long speed range. A fixed gearing can replace the multi-speed gearbox. So previously it was a multi-speed gearbox. That's why this coupling was there. So this was generating the multi-speed. In this case, the multi-speed gearbox is not there. So it's a fixed gearing. Okay. So like you are doing all those activa and all this thing, the gear is one. You are not changing the gear. So a fixed gearing can replace the multi-speed gearbox and reduce the need for a clutch. So in this case, the clutch is removed because starting to end, it will be running with the same power. That's why this coupling between motor and gearbox is gone. Okay, so this configuration not only reduces the size and weight of the mechanical transmission, it also simplifies the drive time control because gear shifting is not required in this case. So this is also a type of electric vehicle which we have seen. Those who are having difficulty in changing gears and all in IC engine based vehicle, they are given this kind of vehicles. Okay, so in this kind of vehicles, changing gear, that problem is not much there. Okay, so this is actually a lighter vehicle with less complexity. Okay, you cannot take this for a long drive, 1,000 to 2,000 kilometer thing. You cannot take it. But yes, within a city, if you want to roam around, and generally the wives are given this kind of cars. Those who are not working, okay, housewives, they just go to marketplace, bring some, do some shopping, and come home. So instead of a bike or something, they can, or a scooty or something, they are given this kind of vehicles. Okay, so this is less complex, easy to drive, and that kind of thing. So similar to the drive train in B, so likewise you can see here this M, GB and D, they are replaced by D, F, G and M. So motor is always there, D is always there, that is the differential, but the GB is replaced by FG. So this is the evolution that you have to show. This question can be asked for 10 marks, and it's very simple to draw. So you practice all these things, but what all things are added, what all things are modified, those things you have to explain. So similar to the drive in B, what we are doing is we are actually the electric motor, the fixed gearing FG, and the differential can be further integrated into a single assembly via both axle points and both driving wheels. So on the axle point and driving wheel, so these three things are put on the axle point of the driving wheel. So the front is the axle driving wheel. So here I made a mistake. I think previous case I told you that this is a differential for the rear wheel. It is not. It is actually for the front wheel, because here you can find this is a right hand driven steering here. So exactly the way we are use it in India. This is the same kind of a thing. So here front wheel is given the actual power, not the rear wheel. So here this is the rear wheel and this is the front wheel. So please do the correction as was told by me. So similar to the drivetrain in B, the electric motor, the fixed gearing and the differential can be further integrated into a single assembly. You can find it here. Okay, so on the differential itself, the fixed gearing and the motor, everything is put together. While both axle points at both driving wheels, the whole drivetrain is further simplified and compacted. So initially it was this kind of a design, okay, lateral kind of a thing. Now it has become kind of a longitudinal. So everything is more compacted here. So the whatever the engine and other all components, mechanical components generally that are there in place of engine. So whenever we open the front bonnet, we find all these things. In electric vehicle, you will find complexity is very less. Okay, if you open the front bonnet of an electric vehicle, you will be finding there are very less amount of components there. So the battery and all these things will be there, battery converter, and all this fixed gearing and little bit of gearbox and all these things. If it is there, it will be shown. So complexity is very less in case of electric vehicles. Now there is modification. So up till this, up till figure C, there was a compaction. So after compaction, research never stops. Now there is a modification. So figure D, E and F, they are actually modifications. So the mechanical differential is replaced by using two traction motors. So in case of there was a differential and this differential was taking care if the vehicle is taking some turn. So if the vehicle is taking a leftward turn like this, leftward turn in this direction, okay, so this is a leftward turn because there is a front side. In that case, you will be finding one wheel is running very fast, so this will have to cover more distance, and this has to cover less distance. Okay, in that case, rotation of left wheel and rotation of right wheel, they will be different. So this differential in front, the same differential or one differential, they will be taking care of that part. That is, left wheel will be rotating less, right will be rotating more. But in this case, that part is also separated. So this is kind of a distributed control kind of a thing. So the mechanical differential is replaced by using two traction motors. So instead of one motor, there are two traction motors. So left wheel is controlled by this left side motor, right wheel is controlled by this right side motor, and there are fixed gearing for left wheel as well as right wheel. So this is a modified design only for electric vehicle. The mechanical differential is replaced by using two traction motors. Each of them drives one side wheel and operates at a different speed when the vehicle is running along a curved path. So that is the challenge, that vehicle is taking turn. Whenever they are going straight, this FGM and this FGM below, both these things are working fine with the same efficiency, with the same outputs. But whenever the vehicle is taking turn in the left side, at the time both this wheels will be controlled by this FG and this motor. Whenever it is taking turn in any direction, so both these right wheels are being controlled by this FG and M. Okay. So this is a very important thing. Each of them drives only one side wheel and operates at a different speed when the vehicle is running along a curved path. That means whenever the vehicle is taking turn, at that time, this top FGM and bottom FGM, their speed, output, and all other things are working in a differential fashion. Next one, further simplified, you are finding that it is integrated with the vehicle tire itself. So in order to further simplify, the drivetrain, the traction motor, okay, can be placed inside a wheel. Okay, so this is a kind of a dream come true kind of a thing for us. So the traction motor, and it can be a drivetrain and traction motor, it is placed inside the wheel. That is a very modern kind of a design. So this arrangement is so called as in-wheel drive. That means the drive itself is inside the wheel. So there's a very modern kind of design. So one or two groups might be having seminar on this, and whichever group wants to work on that, you please let me know, sir, I would like to work on in-wheel drive. So this topic will be assigned to you, obviously with some more modifications that I will see. So in-wheel drive is something which we should really find out what is it. So a twin planetary gear set may be employed to reduce the motor speed and enhance the motor torque. So there is always a speed torque relation. Speed is less when torque is high, and torque is less when speed is high. That thing is always there. So there is a planetary gear set. It may be employed to reduce the motor speed and enhance the motor torque. The thin planetary gear set offers the advantage of high speed reduction ratio as well as inline arrangement of the input and the output shaft. So in this case, it is also a different or discrete kind of a control. So it's a distributed kind of a control, but you are finding that the drive and the motor, it is there incorporated inside the wheel itself. Okay, so it is taking the energy from the battery, it is rotating the wheel, and the motor itself is within the wheel itself. So just find out what is in wheel driving. I will find out some links of YouTube links. Two I have found out already. Some more I will find out and post in the group. Okay, so one is the differential video, another is this in-wheel drive video. So these are specific features of EV. Though differential is there in all the cars, okay, but this in-wheel drive is a feature for EV. We will see to it in a more depth. I will post the links today itself. So this is the last thing. This is also with in-wheel drive. So you can find here the previous thing. It is FG and M. So there is a fixed gearing and the motor in the last most advanced thing. So there is no gearing arrangement shown here, only the motor is rotating the wheel. So this is by fully abandoning any mechanical gearing. So this is the last type. So there is no mechanical gearing anywhere. So only between the motor and the battery there is only motor and battery. So these are the only two things which are in this last, that is the figure F. This is the configuration. So by fully abandoning any mechanical gearing between the electric motor and the driving wheel, the out rotor of low speed electric motor in the in-wheel drive can be directly connected to the driving wheel. That means motor is directly connected to the wheel. The speed control of the electric motor is equivalent to the control of the wheel speed and hence the vehicle speed. So it is very simple to understand that if we want to control the vehicle, we have to increase the motor speed. That means power directly goes to the wheel, and rotation of wheel is actually controlled by the motor itself. Okay. And we are actually controlling the motor through the accelerator and other thing. So this is a very important line. The speed control of the electric motor is equivalent to the control of the wheel speed and hence the vehicle speed. Okay, so by controlling the accelerator, we are actually controlling the rotation of the motor, which are kept inside the wheel only. So this is also an in-wheel drive, and this is an advanced in-wheel drive. However, this arrangement requires the electric motor to have a higher torque to start and accelerate the vehicle. So whatever is this configuration E and F we are finding, so they are actually in-wheel drive, and they are the most latest kind of a EV wheel drive kind of a configuration. So this question can be asked as a 10-mark question, and all the six things you have to explain from the primitive to the most sophisticated, which is the latest configuration. Now we are going to understand what is called as the performance of electric vehicles. So vehicles driving performance, we have module 1, I guess. Now we will be seeing with respect to EV. So the specifications will be fixed. So vehicles driving performance is usually evaluated by its acceleration time. So these are the three parameters: acceleration time, maximum speed, and gradability. EV drivetrain design, proper motor powering, rating, and transmission parameters are the prime consideration. So first one is motor powering, and second is transmission parameter. That means gear ratio and all other things. So how much power is generated and how much power we are able to transmit to the vehicle wheels. So that is kind of a design by transmission parameter. So motor power rating, that means how much power is generated and how much we are transmitting. So these are the main considerations to meet the performance specification. The design of all these parameters depends mostly on the speed, power, torque characteristic. So we will be showing some 3-4 speed, power, torque characteristic, and all these parameters are mainly depending on speed, power, torque characteristic. So power is, I told you that whatever is the vehicle power, that is equal to torque multiplied by speed. So the power, if constant, if we increase torque, speed will reduce. If we increase speed, torque will reduce. So you have to understand like this. In mechanical system also, electrical system, the power is equal to voltage into current. If we increase voltage, the current will reduce. If we increase current, voltage will reduce. In case of mechanical system also, it is like that. Power is equal to speed into torque. Likewise, so performance characteristics of EV, there are three characteristics: traction motor characteristic, tractive effort, and transmission requirement. And the last one is vehicle performance. So let us start with this. So this can be also a 10-mark question. And this is actually the traction motor characteristic. So this can we have seen previously. So this is a variable speed electric motor characteristic. Here you are finding that there are mainly two regions. One is the constant torque region, this is the initial part, and there is the constant power region, which is the latter part. So what we are finding is the torque is initially constant up to a base speed. In this case, the base speed is around 1500 rpm, and after that the constant torque, after that the torque is reducing. So there is a reducing torque in a hyperbolic fashion, and we discussed this before. So what we have to say is up to base speed, the speed of the torque of the vehicle is constant. So this is the initial part. Okay, when the car is starting, and after it reaches the base speed, then we can shift it into the higher gear. In that case, the torque will reduce and the power will remain constant, and this is the constant power, and go to the maximum highest speed region. This is characteristic. In this case, there is something called as a ratio X. What is the ratio X? So maximum speed in this, if we understand, is 5000 rpm. So it is 5000 divided by the base, so 500. So how to find the maximum speed? There also it will be shown in the next graphs or so. So in this case, if we assume that maximum speed of the vehicle can be 5000 rpm, it is not the vehicle speed, it is the rotation of the motor. Okay, vehicle speed can be 150 200 kilometer per hour. That we have to correlate with the rotation of the motor speed. So here actually motor speed, motor torque, and all these things are explained. So if maximum rotation speed of the motor is 5000 rpm and base rotation of the motor is 1500, then X. So X is a very important thing because this decides a lot of things. Okay, so the whole tractive performance of the vehicle is designed by this X only. So here it is 5000 divided by 1500, so X is 3.33. Okay, so we'll be finding that if X is higher, in that case this constant torque region is lesser. Okay, so that graph I will show, and that graph can be asked for another 4 to 5 marks question. Be careful. So typical variable speed electric motor characteristic. Why is it called variable speed? Initially the torque is constant, speed is increasing. Okay, you're finding, and after it reaches to a base speed, then the speed is further increased and the torque is reducing and the power is keeping constant. Okay. So standard variable speed electric motor drive characteristic is shown here. So we have seen this characteristic previously as well. A low speed means less than the base speed. So motor rotation speed is less than 1500 in this case. The motor has a constant torque. It is written here. And in the high speed region, higher than the base speed, the motor has a constant power. So in that case, torque is reducing in hyperbola form. So there is a hyperbola characteristic. So this characteristic is usually represented by a speed ratio X. So I told you what is X. It is the maximum speed versus base speed ratio. This is a very important parameter in any EV. So in low speed operation, voltage supply to the motor increases with the increase of the speed through the electronic converter while the flux is kept constant. So in this region, the flux in the motor is kept constant. And in the higher case, the flux is actually weakened. Flux is reduced. As the flux is reduced, motor speed is increasing. So at the point of the base speed, the voltage of the motor reaches to the source voltage. So in this case, input voltage and motor voltage, they are kind of the same. After the base speed, the motor voltage is kept constant and the flux is weakened. That means flux becomes weak. In this region, the flux and torque both drops like a hyperbola with increasing speed. So flux and torque, they are actually directly proportional. Flux and speed, they are inversely proportional. So up till this, flux was being increased, then flux is constant here. So input voltage is equal to motor voltage. And after this point, the flux is reduced. As flux is reduced, in that case, the speed of the motor is increasing. So these are the two regions. First region is called as constant torque region. In this case, flux is being increased continuously. It goes up to a base speed. After the base speed, we are shifting gear and we are taking the vehicle into higher speed region. In this case, the torque is reducing like a hyperbola. In this case, the flux of the motor is reducing like a hyperbola. But in this case, the power is kept constant because speed is increasing. So torque is reducing, speed is increasing, power is constant because power is equal to torque into speed. So initial case, speed was less, torque was high, and after base speed, torque is less, speed is high. This part you should be able to explain very properly. So this is actually the traction motor characteristic. Now there's a very important graph you are supposed to see. There are three different X value that they have explained. Okay, so maximum speed, whatever it is, in this case you are finding base speed is very less. Base speed is around 600 or 800. So in this case, how to find this X? So maximum speed is 5000. So 5000 divided by this base speed. Okay, it take it around 800 or so. So 5000 divided by 800 comes almost equal to 6. This is the second type. This is the second gear actually. In this case, you are finding that base speed is actually a little bit higher. Base speed is around 1000, maybe around 1250 or so. Okay, and highest speed is 5000. So what is the X? In that case, 5000 divided by 1250. So that comes to be almost 4. In the last case, this is another gear. Okay, in this case, the base speed is 2500 and maximum speed here for this vehicle we have taken as 5000, and 5000 by 2500 is constant power region. So this graph you have to explain very properly. So figure shows the torque speed profile of 60 kilowatt motor. Okay, so there's a specific example. So this example, if you can write in the exam, it will be very good. So figure shows the torque speed profile of a 60 kilowatt motor. So again, I'm telling you, these speeds are not vehicle speed. These speeds are actually rotational speed of the motor. Now we have seen that motor is fitted in the wheel itself. Okay, so the way the motor is rotating, the vehicle is will be rotating as a function of that. So this figure shows it's a 60 kilowatt motor, same motor run in different 3x ratios. X is nothing but maximum speed divided by base speed. So it is clear that with a long constant power region, X is 6. So this is the constant power region. It is shown in the previous thing that this is the constant power region. So after the base speed, the power becomes constant. So when X is 6, that means base speed is less. Lesser is the base speed, maximum speed by base speed ratio increases. So in this case, base speed is very less, around 800 rpm or so. In this case, we are having a long constant power region like this. So it is clear that with a long constant power region, because x is 6, the maximum torque of the motor can be significantly increased. So whenever you are reducing the base speed, the initial constant torque region becomes smaller, but the amount of torque is higher. So you can find here, this is x is 6, torque is very high, almost 700 Newton meter, and this is giving us a higher or wider constant power region as well. So try to understand this graph very properly. It is clear that with a long constant power region, x is equal to 6, the maximum torque of the motor can be significantly increased, and hence vehicle acceleration and gradability performance can be improved, and the transmission can be simplified. So this is the first type. Second case, each type of motor inherently has its limited maximum speed ratio. Now, who decides what is going to be the base speed? That depends on the type of the motor that we are using. So in the second module, we have seen mainly four types of motor: DC motor, induction motor, BLDC motor, and SRM. That is the switched reluctance motor. So here, those understanding will come, because any motor you cannot use for any EV. So what kind of uh, torque speed characteristic you want, depending on that we choose the motor. So each type of motor inherently has its limited maximum speed ratio. So we are finding that if we are running with constant power with x is equal to 2, in that case we are finding that the constant torque region is quite high, but the speed in that case is not enhanced very high. Okay, for constant power region with x is equal to 4, we are finding that initial power we are getting is higher than x is equal to 2 but lower than x is equal to 6. So how much maximum initial power we can get and till how much speed, that is actually decided by this x factor. So each type of motor has its own limited maximum speed ratio. For example, a permanent magnet motor, so PM motor, I told you, PM motor has X less than 2. That means PM motor is in this region. That means its initial torque will be quite less. Base speed will be higher, but initial torque will be quite less. So that is a PM motor, because its difficulty of field weakening due to the presence of the permanent magnet. So permanent magnet, we cannot weaken the field because permanent magnet field is constant, so we cannot weaken the field. So in that case, if we want only a high starting torque region to go for quite a longer amount of time, so for higher base speed we want a kind of a constant torque. That is the requirement. In that case we are going to use this x is equal to 2 ratio. Switched reluctance motor may achieve x greater than 6. So you are finding this thing, x is equal to 6 or x greater than 6. That means tremendous high starting torque. Okay, and very wide range of constant power region. That means very wide range of speed variation if we want. So huge amount of starting torque and wide range of speed variation. If we want that, in that case we have to use SRM motor. So there's a very great flexibility this SRM motor is offering, because it can have x greater than 6. In that case starting torque will be very high, okay, for a lesser base speed though, but we are having huge amount of range for constant power. So whenever the constant power is there, we can maneuver with the speed of the motor. So switched reluctance motor, we can have higher range of variability in the speed, but on the contrary permanent magnet motor we cannot vary the speed too much. Switched reluctance motor is giving us very high starting torque for lesser base speed. Permanent magnet motor does not give us very high starting torque, but for wide range of base speed it can keep a constant torque. So this is actually a very good example, speed torque profile of a 60 kilowatt electric motor with x is equal to 2, 4 and 6. So this was the first performance characteristic. There is a traction motor characteristic. We will start with the second one, that is a tractive effort and transmission requirement, and this is the most important part what I find. But there are three graphs, at least one graph we will do. So what we are finding is tractive effort developed by a traction motor on the driven wheel is given by Tm, Ig, I0, eta T, Rd. All these things we have done, and the vehicle speed is actually given by pi nm Rd 30 Ig I0. So what are all these things? So Tm is nothing but the in Newton meter, nm is the nm is the motor speed. So here nm is the motor speed rpm, and v is the vehicle speed meter per second. Ig is the gear ratio of the transmission, and I0 is the gear ratio of the final drive. Eta T is the efficiency of the whole drive line from the motor to the driven wheel, and Rd is the radius of the drive shaft. driven vehicle. So all these are mechanical features of the mechanical specification of the vehicle. But main thing we should understand is FT. This is the tractive force, how much force you are applying to drive the vehicle. TM is the you can say this is the motor torque, how much is produced to uh, keep the vehicle forward. V is the vehicle speed, and NM is the motor speed. So whichever motor we have kept inside the vehicle to run the vehicle is given by the NM. And RD is called as the radius of the driven wheel. That means whatever wheel is there, that is actually RD. So we will only see this introductory part of the tractive effort. I will do the other part, those three graphs, in the next lecture. So this is the last paragraph that we are doing. The use of a multi-gear or single-gear transmission depends mostly on the motor speed torque characteristic. That is, whether we want to drive the vehicle with the same speed, same power, or we want to have a different speed torque ratio from the vehicle. Depending on that, we have to design the multi-gear, or we have to choose, rather design, we have to choose a multi-gear or single gear system. So if we are happy with Activa kind of a scooter, whatever happens, we cannot change the gear, or we cannot drive more power from the system. We are happy with single gear system, go for it. So single gear electric vehicle is available, multi-gear electric vehicle is also available. So the use of multi-gear or single gear transmission depends mostly on the motor speed torque characteristic, and we choose the vehicle with single gear or multi-gear. At a given rated motor power, if the motor has a long constant power region, that means X is equal to 6, we have seen in the previous graph, a single gear transmission would be sufficient to have high tractive effort at low speed. So very important thing they have said, that whenever the power is 6 or X greater than 6, this kind of thing can give you a single gear vehicle. So for single gear vehicle, what we are finding is the X value has to be very high. Okay, that means base speed low, highest speed is very high, and initial starting torque is very high. So that is actually a single gear kind of a vehicle. So at a given rated speed, if the motor has a long constant power region, like this, a single gear transmission will be sufficient for the high tractive effort. So long constant power region I had shown you like this. This is a constant power region which is very long. And means X is greater means it's a long constant power region. So in that case, single gear transmission will be sufficient for high tractive effort at low speed. Otherwise, a multi-gear, more than 2 gear transmission has to be used. So last thing I'm telling you, so here X is equal to 2, this can be a multi-gear system, or X is equal to 6, this can be a single gear system, or we can mix all these three. Okay, so 3 gear system, 2 gear system, 1 gear system, all these things we are going to see in the next day. So in the next lecture. So this is the next topic what we will discuss. That is the, this is a 3 gear system, tractor versus vehicle speed with traction motor X is equal to 2 and 3 gear transmission. So this is the X is equal to 2, the lowest case. Okay, and there's a 3 gear transmission. So we are changing the speed and torque the way we want. So there are 3 regions. First gear is ABC, second gear is DEF, and third gear is GFH. And be careful, in the book of Ehsani, this GFH is written something wrong. I think they have written GEH. Okay, so this has to be made GFH. So next lecture will start from this tractive effort and transmission requirement graph. That's all from me now. Thank you.